We're now going to look at a more complicated probability problem. This one has enjoyed much recent vogue, and in fact it now has a Wikipedia article devoted to it, and that article is called The Infinite Monkey Problem. And I used the version of the story put forward by Sir James Jeans, but the Wikipedia article focuses on his rival Arthur Eddington and traces back the idea even earlier. But I'm going to stick with this one. There are some mistakes in the calculations in the Wikipedia article. Not so much mistakes, but calculating the wrong probability because they didn't actually consider a typewriter in some of their calculations. But anyway, so the question is, can monkeys type Hamlet? We first need to determine the probability of Hamlet appearing in a random stream of characters. There were no computers in Jean's era, so we'll assume a typewriter. And on a typewriter, there are 44 keys, and I estimated that there are 1 million characters in Hamlet. It turns out that there are closer to 100,000, but don't worry about that, and we're not going to worry about the shift key on the typewriter. The calculation in the Wikipedia article actually only deals with the letters, so I guess they didn't care if numbers were inserted at random. The probabilities are small in either case, and I'll probably get you to fix this one up for the actual length of Hamlet as a homework problem. But anyway, so that's the question. If monkeys are randomly typing, would they ever type Hamlet or anything else that was legible? So if we're considering a typewriter, the probability of getting any character is 1 out of 44. So then what that means is we can calculate the probability of getting Hamlet in a random stream by saying that the probability of getting the first character right is 1 in 44. The probability of getting the second character right is 1 in 44. And with my assumption of 1 million characters, that means to get Hamlet randomly, the probability is 1 over 44 raised to the power of 10 to the 6th. To evaluate numbers like that, we actually have to resort to logarithms. So the calculators have trouble with very small and very large numbers. So if we take the log to the base 10 of 44, it turns out to be 1.6434553. And I remind you about the basic properties of logarithms. So what that means is, using those equations, we can write that 44 is 10 to the power of 1.643453. So what that means is that we can put that into our equation. We can replace 44 with its representation as a power of 10, and we can work out what that probability is, and you can see that it's incredibly small. What we did there, though, was we calculated the probability of typing Hamlet if we typed 1 million characters at random. The probability should go up if more characters are typed, and the question is, by how much does the probability go up? Well, we have to make some assumptions. How many monkeys, how many keystrokes? Let's assume that the total number of monkeys that has ever lived is 10 to the 10. And further, let's let each of them have lived for the age of the universe. That's 10 to the 18 seconds. Finally, let's assume they can hit 10 keys per second. Clearly, the probability will go up. How do we calculate it? We use a method that we've already introduced. What we'll do is we'll calculate the probability that they don't type Hamlet. So the probability of typing Hamlet at random is that number there. The probability of no Hamlet is 1 minus that. So with 10 to the 29 keystrokes, we can type the probability as that original probability raised to the power of 10 to the 29. If you like, we can pad either end of the sequence by 1,000,000 characters so that we're looking at groups of 1,000,000 every time, but that doesn't actually make any difference with numbers like this. So to evaluate that probability, we can use this little power series expansion, which is good if the modulus of x is less than 1. So doing that and just retaining the first term, you can see that the probability of no Hamlet is given, and then we can refigure that for the probability of Hamlet, and you can see it's 10 to the negative power, and what we're looking at there is over 1.5 million. This could be said to be the meaning of never. Monkeys are not going to ever type Hamlet or even the sonnet, and the probability of even getting a coherent sentence is rather small. In fact, when I post this online within Blackboard, I'm going to post the actual effort of a group of monkeys so you can see what monkeys would actually do hitting keyboards at random. Okay, we'll end this little session here.